Dear students, continuing with the review of question paper December 19, January 20, today we will discuss the module number 1, question number 2. The question number 2a problem statement, what he asked is two 12-volt batteries with an internal resistance of 0.2 ohm and 0.25 ohm respectively are joined in parallel. These two batteries, 12-volt batteries, are connected in parallel with the internal resistance of 0.2 ohm and 0.25 ohm resistance respectively. And a resistance of 1 ohm is placed across the terminals. Means the two batteries are connected in parallel and the another resistance is connected across these two parallel combination batteries. Then he asks you to find out the current supplied by the each battery. Means the current supplied by battery number 12 with 0.2 ohm internal resistance and the current supplied by 12 ohm battery, second 12 volt battery with the internal resistance of 0.25 ohm. Then how to go about this solving this particular problem? You have to find out the current I1 and I2. Then here you have to apply the Kirchhoff's voltage law or KVL. Therefore, you can observe or irrespect the given circuit. Here you have got two independent loops. There are two independent loops. Therefore, you have to choose two unknown currents and in any part of the circuit you want, and you can mark the current direction in any direction you want. But the usual convention is that the 12 volt battery, they are supplying the currents. The current is supplied by the positive terminal. Therefore, the usual convention is you have to take one current from the 12 volt battery with a 0.2 ohm resistance here. The another current I2 can choose here in the 12 volt 0.25 ohm internal resistance. Therefore, you have to mark the current direction also. That is I1 and I2. Then, what is the current flowing through the 1 ohm resistor? You have to apply the Kirchhoff's current law at this point. Here, the incoming currents are I1 and I2, then outgoing current must be I1 plus I2. Therefore, I will mark the current I1 plus I2 which is flowing in the 1 ohm resistance. The next step is to mark the nodes or junctions. Okay. The first I will mark A, then B, C, D, then I'll go for F and G. These are the nodes what I have written. Then you have to write, here there are two unknowns. What you have to write is the mesh equation. The two mesh equation what I am considering here is, first mesh is, what I am considering here is A, B, C, G, A. A, B, C, G, A. You have to move all along the whatever the mesh, the path you are writing here, A, B, C, G, A. Therefore, I will write here first the mesh equation, then now we will analyze here how we are writing this equation. You are moving from A to B. You are start moving from A towards the B. In that case, for a battery, irrespective of the current direction, we are moving from the negative terminal of the battery to the positive terminal of battery, that is the rise in the potential. Therefore, this you have to take it as a positive 12 volts. Then the voltage drop across the 0.2 ohm resistance is 0.2 into I1 is the voltage drop. Then we are moving from A to B. The current is also moving from A to B. You are moving the same direction as the current direction. Based on our convention, this drop you have to take it as negative drop. That is minus 0.2 I1. Because we are moving from A to B, the current is also moving from A to B. You are moving in the same direction as the current direction, the drop is negative. Then you have to move from C towards G. In this case, the voltage drop across 0.25 ohm resistor is 0.25 into I2. 0.25 into I2. But however, we are moving from C to G. Means we are going against the current direction. Therefore, this drop you have to take it as a positive. Therefore, it is 0.25 into I2. Then we have got a battery here. We are moving from G towards G. Then we are moving from positive terminal to negative terminal here, positive to negative. Therefore there is a fall in the voltage here, there is a fall in the voltage. Therefore I am writing here minus 12 is equal to 0. You have to simplify this equation. What we are getting is minus 0.2 I1 plus 0.25 I2 is equal to 0 is the first equation. Then the next loop what I am considering here is GCDFG. That is, I'll write here the mesh G, C, D, F and Z, back to Z. Then the mesh equation as I'm writing here. We'll see this, the mesh equation here. Now we are moving from G to C here. You look into the mesh G to C, C to D, D to F, F to G. In the same direction we will move. That is F to C. First element what we are getting here is the battery. You are moving from negative to positive. Negative to positive, therefore rise in the potential. From negative to the positive, rise in the voltage, therefore 12 volts. The drop across 0.25 ohm resistor is 0.25 into I2. You are moving from G to C. The current is also moving from G to C. Therefore, this drop is negative. That is minus 0.25 I2. Then from D to F, that is the voltage drop is I1 plus I2 into 1 ohm resistance. You are moving from D to F. The current is also moving from D to F. This drop is also, you have to take it as negative. That is minus I1 plus I2 into 1, that is equal to 0. Then the simplified the mesh equation what we are getting here is minus I1 minus 1.25 I2 is equal to minus 12. This is equation number 2. We have got two unknowns of I1 and I2. Then you have got two equations. Therefore, you have to make use of your calculator and calculate what is the value of I1 and I2. If you are using a calculator, you are getting I1 is equal to 6 ampere, I2 is equal to 4.8 amperes. It is very simple. Just you have to look into the numerical what is given. Based on the given numerical and what exactly asked for, accordingly you have to choose the unknown current based on the independent loops here. It is a KVL equations. Then you have to try to choose the minimum number of currents. How to choose the minimum currents? You have to look into the independent loops. Independent loops. You have got two independent loops. Therefore, you have to take only two unknown currents so that we are getting only two equations and only two unknowns. For solving this equation is very easy. This is how you have to solve the numerical on KVL. Go to the next part of the question number 2, that is question number 2b. It is on the AC fundamentals. The equation for an AC voltage is given by V is equal to 0.04 sine 2000 t plus 60 volts. Determine the angular velocity, instantaneous voltage when t is equal to 60 microsecond, and also he asks you to find out what is the time represented by 60-degree phase angle. It is asked for 6 months. He is given the instantaneous, that is the value of the voltage in the equation form in terms of maximum value and omega. It is a very simple. First you list out the data given. What data is given? Only simple equation. V is equal to 0.04 sine 2000 t plus 60. That is what I am writing here. Then he asked for the different quantities such as frequency F, angular velocity omega. Then he asked the instantaneous voltage when t is equal to 60 microsecond, and also asked you to calculate what is the time represented by 60-degree phase angle. For 60-degree phase angle, what is the time? For this, what you have to write is, you have to write our standard AC voltage equation. First you will note on the given quantity V is equal to 0.04 sine 2000 t plus 60. Now I will write the standard form of the AC voltage, that is V is equal to V max sine omega t plus theta. In the similar fashion I am writing the standard equation. Just what you have to do is, you have to 1 to 1 you have to compare. This is V here, therefore the Vmax is nothing but 0.04 and the omega is nothing but a 2000, that you have to take it up. Therefore, first what is asked is the frequency. For calculating the frequency, what we need is the angular velocity first. First we will calculate the angular velocity, then we will move for the frequency here. Just you have to compare here. Then how to find out the angular velocity? Just for comparing this. It is 2000 t is nothing but your omega t. Therefore, you have to leave t apart. Then you have to compare omega with 2000. Therefore, what I am getting here is omega is equal to 2000 radians per second is the angular velocity. Then the first thing what he asked is the frequency. The frequency we are getting from the angular velocity. We know that omega is equal to 2 pi f. From that you have to find out what is the f. Therefore, what I am writing is omega is equal to 2 pi f. Therefore, f can be calculated omega by 2 pi. That is omega by 2 pi. Then I am substituting the value of omega as 2000 and 2 pi. Then what I am getting here is the frequency is 318.30 hertz. This is simple, straightforward the question he asks. Then the third what he is asking is instantaneous voltage when t is equal to 60 microsecond. It is a equation is given, then at a t is equal to 60 microsecond he asks what is the voltage, instantaneous voltage. You have to put here t is equal to 60 microsecond and you have to calculate what is the voltage. Therefore, I will write here V is equal to 0.04 sine 2000 into 60 into 10 raised to 6 because it is 60 microsecond is given plus 60. Just substituting the value of t here in this equation. Therefore, the instantaneous value at 60 microsecond, what I am getting here is 0.0346 volts is the instantaneous value when t is equal to 60 microsecond. Then the last one is a little bit tricky. Instead of asking a time period, for 60-degree phase angle, what is the time? First we will find out the time period. How we are finding out the time period? Time period is 1 by f. 1 by f is the standard equation for time period. Therefore, what I am getting is 3.14 milliseconds is the time period for one cycle. One cycle corresponding to 360 degree. 360. For 360, what is the time taken? 3.14. For 60 degree, what is the time? That is only you have to calculate. Therefore, for 60 degree, t is equal to 60 divided by 360 into 314. Because for 360 it is 3.14. For 60, you have to calculate for 60 degree. Therefore, 60 divided by 360 into 3.14 millisecond. Therefore, for 60 degree phase angle, the time is 0.523 millisecond. This is very simple, the numerical on AC fundamentals. Then you will move on to the question number 2C. Is asked the theory question. Explain the generation of single phase AC EMF, induced EMF with suitable diagram. Okay, he asks you to have to explain the generation of single phase AC. That is the AC voltage or AC current you are getting from the AC generator. That is nothing but your alternator. And the principle of operation on which the AC generator works is the electromagnetic induction, that is Faraday's laws of electromagnetic induction. Based on these two parameters, just you have to explain how exactly the AC voltage is inducing in an alternator. Sinusoidal voltage, the first statement what I am writing here is sinusoidal voltage are produced by AC generator. AC voltage or current is produced by the AC generator. AC generator, also called as alternators, operate on the same fundamental principle of Faraday's laws of electromagnetic induction. That is alternator, the voltage induced in the alternator or any generator, it is based on Faraday's laws of electromagnetic induction. Then what is the Faraday's laws? The Faraday's law first law states that whenever a magnetic flux linking with a conductor or coil changes, an EMF induced in it. It is a one way of stating the Faraday's law. In other words, also is true. When the conductor cuts the magnetic flux, then there is an induced also. That is the Faraday's law, putting the Faraday's first law in the another way. Then the Faraday's second law gives the magnitude of induced voltage, that is given by, it is a rate of change of flux. The magnitude of induced voltage is given by a rate of change of flux. Then to generate the electricity, then the three things are necessary. One is the number of turns in the coil. The number of turns in the coil or the conductors are necessary. Then the second necessity to generate the electricity is strength of the field, or we need the magnetic field. Then the third one, what we want is the relative motion between the conductors and the magnetic field. That is the third one, that is speed at which the coil or a magnetic field rotates. This is how there is a AC voltage is generated because of the alternator. The alternator is working on Faraday's laws of electromagnetic induction. To generate the electricity, three things are necessary: conductor, magnetic field, and the relative motion between the conductor and the magnetic field. Then with the help of diagram you have to explain. Just I am drawing here. Sinusoid is generated by rotating a magnetic field at a constant angular velocity within a stationary coil. What I am doing here is I am keeping the conductor stationary and I am rotating the magnetic field. That is, sinusoidal wave is generated by rotating magnetic field at a constant angular velocity within a stationary coil or stationary conductor. Just I will demonstrate here with the four different diagrams. In the first diagram, you can see here the magnetic flux produced by the magnet, which is moving in the same direction as the number of coils. The conductors and flux are moving hand to hand. Therefore, there is no induced voltage. Therefore, in the external circuit, there is no current is flowing in the external circuit. When it is start moving here, it is goes on cutting the number of conductors here. The number of conductors, because here it is not linking with the conductor here. The flux is producing here. Then when it start cutting these conductors, then the current start flowing. When there is a maximum flux is cut by the magnetic field, it is when it is going through an angle of 90 degree. Therefore, you can see here, when it is going through a 90 degree, then it is producing the current, induce the voltage, and the current start flowing from here to here. It is in this direction, that is in the anti-clockwise direction. Then when it moves a further 90 degree, once again what happens? The coils and the magnetic field, they are moving in the parallel to parallel. There is no flux linking with the coil by the magnetic field. Therefore, once again the current is 0. Now, further we are moving 90 degree, then can see the polarity here. Previously here you have got a N and S. Now you have got S and N here. S and N here. But the flux cut by here is, once again it is a maximum. But you can see here these coils are come under the influence of the another set of poles. Before these having under the influence of N pole, now they are come under the influence of S pole. However, the current is maximum, but it is changing its current direction. Means there is alternating current or the alternating voltage is producing by rotating a magnetic field in stationary armature coil. That can be demonstrated with the help of a sine waveform. You can see here at position number 1, the induced voltage is 0 here. When it is rotating through an angle 90 degree, it is cutting a maximum flux and you are getting a maximum voltage here at position 2 with a positive value. Then from here to here afterwards, from 90 to 180, then the flux linkages goes on decreasing, the induced voltage goes on decreasing. When it is 180 degree, then the induced voltage is 0 because the flux and